But when I talk about this, what technologies are really the most essential in 2018? And this is where we get into 8 areas of technology that I talk about. Now, I've expanded this over the years, and I think that these 8 areas of technology are going to be the most important for you to understand will change the world, and to understand in the context of modern business as well. Right, let's see if you sort of agree with some of these. But what's really interesting about technology, before I jump straight in, is understanding that it's not actually technology that drives the change, right? It's our collective response to the technology. And Paul Sappho's a really bright professor down at Stanford, talks about this cultural change. Virtual reality, for example, it was around 30 years ago, and now it's in your pockets, right? In all of your smartphones. Like the impacts there, electric vehicles, for example. They were already doing them 30 years ago. In fact, they were already doing electric vehicles. Henry Ford's wife drove an electric vehicle, right? So, you know, it does take a long time. And yes, some of that's technology, but a lot of it's cultural appropriation, right? But the first one's about data. Basically, data is an unlimited resource. We're going to be generating so much data by 2025 that we're not going to know what to do with 99% of it. We're going to be generating about 163 zettabytes of data per year by 2025. That's the equivalent of a billion high-definition movies, right, per year. And we're only going to be able to use about 1% for anything useful. And this is why we need data. Data is the foundation for our understanding and our decision-making. And then we transfer that into a form of information. That information then gets discussed and put into a form around knowledge. Here's our knowledge base. But really, wisdom is the thing that we're trying to get to. And that's why we're here learning. That's why we're learning from each other. And that's why we're trying to solve problems in the world, that wisdom that leads us to real-world decision-making. Okay, then on into autonomous worlds, artificial intelligence. So Andrew Ng used to be the chief science officer of Baidu. He was the guy that founded Coursera. Coursera was founded on the idea of getting artificial intelligence courses, ironically enough, out into the world. And Andrew Ng says artificial intelligence is the new electricity. It's that pivotal moment in history that everything changes. In the early 1900s, when electricity came online for everyone, everything changed for us, right? You couldn't imagine life without electricity. Now, within a few years, you're not going to be able to imagine life without artificial intelligence. So this is what artificial intelligence does. It's a simplistic way of looking at it. In the data model of data, information, knowledge, and wisdom, AI gets all the drudge work out of the way, right? So data, information, knowledge, it can do that all automatically, collecting from all the sources and trying to infer meaning in those data sets, and then passes it along to you and says, hey, make some more sense out of this. Use your wisdom. And that's where we come in. So what's really interesting about artificial intelligence, a lot of people are saying it's going to destroy the economy, it's going to take away jobs and whatever. It's just going to change things, and it's going to change the way that we work. But what's really fascinating is it's going to have a huge economic impact on the world. They actually think that it's going to provide a $15.7 trillion boost to GDP worldwide. And it's interesting how it's split as well. Labor productivity improvements about 6.6 trillion, and increased consumer demand 9.1 trillion. So we're going to want more things out of this economy that's driven by artificial intelligence. We're also going to change how we become productive as humans, because we're pretty terrible at being productive, right? We don't need people in the front of McDonald's like taking orders. We don't. Let's hope that you never do that, because you won't have that job for very long. Okay, so I talk about human and the machine. It's about redeployment, not unemployment. It's about augmenting ourselves. Suddenly, if you've got access to all this processing capability of more data sources than you've ever had before, you become almost superhuman in a way. And that superhumanity is going to be the way that we operate going forward. The third thing that I talk about is the Internet of Everythings, or you might have heard the Internet of Everything, also known as like the fourth industrial revolution, cyber-physical systems. The idea that everything's got a sensor in it. It collects data, it reports it back. You can basically use that for decision making, and you might even have systems that are driven by artificial intelligence automating entire factory manufacturing lines, right? So it's a really important thing to understand that this is going to be the eyes and the ears of the world all around us, in cities, in factories, in schools, in this classroom. And the installed devices by sector is going to be huge. Even in the home, does anyone have an Amazon Alexa here? Yeah? Okay, Marina does. But you're all going to have more of that going forward, right? But yeah, up to about 25 billion installed sensors by 2025, 2024. It's a pretty interesting world. We're being watched more than ever, right? Then I get really excited about this next subject, abundant energy. And later on, I'm going to go into specific industries where these sort of intersect. Now, I travel a lot to Alberta and I speak on energy. I'm not particularly popular in Alberta, and this is why. Modern business is going to be determined, the winners of modern business are going to be determined if you own a clean, sustainable energy supply, storage, and distribution, then you own that modern business landscape. Why do you think that places like Facebook and Google and these large tech companies are creating, carbon neutral, 100% renewable energy data centers and working on battery technology? And they're going to control everything, right? Independently. Jeremy Rifkin, who I chatted to last week, says that the sun never sends you an invoice, right? I really like that thought as well. But with fossil fuels, it's waning. They actually think by 2030, it's going to be about $10 a barrel for oil. Now, there's a lot of trends coming in to actually reduce down the amount of oil that's going to be burnt in the world. We have to make a change, as the world's going to be irreparably damaged. As some people say, it's already irreparably damaged. But the cost of solar's dipped exponentially. And the amount of installations has gone up exponentially as well. So we're actually at this point where oil will be on its way out a lot quicker in the future, but the amount of installations, the way that we can actually generate electricity is becoming more ubiquitous. It's everywhere. And then for the first time at the beginning of last year, it was actually found that two different funds, one was for fossil fuels, that's the one at the bottom, and one was for clean energy, that's the one at the top here, actually diverged. And for the first time, the fossil fuel one started to dip. You even had one of the board members of I think it was Chevron most recently, actually came out and made a tweet about, maybe there is something in the fact that renewables is raising and fossil fuels is dipping. That tweet disappeared about 10 minutes after that. I'm sure it was a good day for PR in that company. But really, clean energy is the thing that people are bullish about, the thing that's really going to redefine what the world is. Okay. Decentralization. A lot of people have said, are you going to talk about Bitcoin? Are you going to talk about cryptocurrency? Are you going to talk about the blockchain? A little bit, not a lot. But blockchain's super important. This part of the presentation to me is like me talking about TCP IP and the internet. It's a backbone, it's a protocol, it's a way that it works. It's not very interesting. What is interesting is what you put on top of it, right? So for example, Bitcoin is on top of the blockchain, which is really interesting from banking the unbanked, having a different level of investment in something that's unsecuritized but actually has got scarcity and it's like a monetary system. Right? Who's got Bitcoin in the room? Oh dear. Yeah, really? Okay. It's kind of interesting. Yeah, I never suggest getting into crypto, but I've got some. Okay. But what's really interesting is that the blockchain is a software protocol that it provides secure encrypted network, and it's got decentralized and open ledger that allows for anonymity. It's an accounting system. That can be used for so many different things, right? Imagine, for example, SWIFT payments across borders, right? That system's 44 years old. And now you've got new blockchain-based systems like Ripple and whatever that can do cross-border payments with little friction and almost zero cost. And it's going to put this old technology out of the way, disruption. This is going to probably be one of the most disruptive technologies in the future, just for the backbone of the world. And there's lots of people working in capital liquidity, middleware, protocols, and infrastructure. Get away from thinking about Bitcoin, get back into thinking about blockchain. And actually, a lot of people are expected to adopt that. Once it starts getting into the backbone systems, and you'll see that coming in banks and credit card systems and the such like first, you're going to see it everywhere. Any time that you sign an agreement, that's going to go on the blockchain. You buy a property, that data record is going to be stored on the blockchain. It means that you no longer have to store a centralized version of that. It's distributed. So there's nothing to be hacked, and there's nothing to be removed, except for the exchanges, and you've got to be really careful about what exchanges you use. Okay. And then into open medicine. I think medicine's probably one of the biggest areas that will be impacted. We care very deeply about human health. It's been invested in a great deal over time. But really, I sort of say that waiting rooms are dead. The doctors that we see today are not necessarily going to exist in the same form going forward. I love this quote by Dr. Derek Topol. Go and watch some videos of this guy. When I went to medical school, the term digital applied only to rectal exams. Now, this is an older doctor, and he actually travels the world and extols the virtues of what it means to use digital and platforms. You can have a mobile phone now that you can measure your heart rate on. You can have add-on devices to that mobile phone that suddenly turns it into all sorts of different medical devices as well. There's been a lot of research in that area. In fact, this comes out of an X Prize for the Tricorder challenge. Do you remember in Star Trek? Like Bones runs up and scans someone, what's wrong with them? Well, they actually built this system. It diagnosed about 14, 15 different conditions using a mobile device that you can just buy out of a store. It's pretty great, and it's a huge leap ahead. This is actually a cut from the film Ender's Game, but this is actually a cranial surgical robot, and it's real. It does exist. But we're in this future world of robotic surgery. In fact, a lot of the graduate surgeons in the US now, about 3/4, are actually struggling to get employment because robotic surgery is so prevalent. And the doctors in charge of these are keeping it to themselves, right? Hands up who'd actually be operated on by a robot. Right, so everyone with their hands down would rather have the shaky hands of a human. Good luck. Right. And then medical research is getting super interesting as well. You can actually edit DNA using CRISPR-Cas9, and you can fix congenital diseases. Now, it's still in the lab, but in China, they've already been doing it on humans, and they've noticed some improvements. It's not conclusive yet, but in the future, you'll be able to solve problems that are congenital through the use of therapies like CRISPR-Cas9. And it's been around for a long time, about 30 years, and it's just becoming of age. Okay. And these last two of the exponential 8 pieces of technology that I talk about a lot are getting really, really into the realms of the future somewhat. So nanotechnology. So a great professor, Richard Feynman, said, I want to build 1 billion tiny factories, models of each other, which are manufacturing simultaneously. The principles of physics, as far as I can see, do not speak against the possibility of maneuvering things atom by atom. It's the idea that you can manufacture at the atomic scale and actually build machines at such a small size that they can be used for applications that we've never thought about before. So this was done by the University of Alberta. This is a maple leaf that was put together for Canada 150 that's 10 nanometers wide. How big is 10 nanometers? Well, you can fit 10,000 of them across the width of a human hair, which is 100,000 nanometers wide. 10,000 of these. Imagine what you can do with tiny machines that can be manufactured at this scale. And you can operate literally at the cell level, right? And that's exactly what people are experimenting with. So there's some technology that's really just in the laboratory and using fish and pig cell organisms that have got cancer in them. And you can activate some nano robotics that go in, and at a certain frequency of light, they destroy cancer. So imagine if you've got cancer, you've been diagnosed, and you can walk into the hospital in the future, and someone injects you, and then you might go under a certain frequency of life that's probably safe for you. And 24 hours later, the cancer in your body's been killed by machines. That's a huge leap ahead. Another huge leap ahead is around quantum computing. Now, this is the part of the presentation where I put my hand up and say, I'm not a quantum physicist. I will talk about these concepts in a very high level. Anyone watching the video of this presentation will probably put anything in the sort of comments below and start to rip it apart, but I'll keep it simple. Quantum computing is a distinctly new way of harnessing nature. It will be the first technology that allows useful tasks to be formed in collaboration between parallel universes. Now, if you've got a normal computer that operates as with classical bits, 0 and 1, it can be one or the other. And a combination of those bits means instructions. Those instructions turn into computer programs, and that runs the computers that we have in the world. Well, qubits, or quantum bits, actually operate in a completely different way, where they can be 0 and 1, 0 or 1, or any position in between all of them, all the same thing at any point in time. So you actually create a solution space that's got a number of probabilistic outcomes, and it can use a number of algorithms that actually determine the final answer infinitely quicker than traditional computing. So here's one example, and we've got a hackers conference downstairs, so I find this kind of interesting. So say if you've got a password, a conventional way of guessing what the password is look at every single machination of what that password could be. And then after 1,000 years, here's your answer, right? Sure, you might stumble across the answer earlier on, but if you've got really strong passwords, which I hope that you do, it's going to take a long, long time. With quantum computing, you'll be able to look using superposition across the entire possible space of combinations of those password constructs, and then look at all the sequences, and then use entanglement and other quantum effects to then use probabilistic theory to really narrow it down, and within a couple of seconds break it. So here comes a problem. And this is why banks and a number of other organizations are actually investing in quantum encryption. Because all encryption will be broken immediately by a quantum computer that finally reaches that state of quantum supremacy, the ability to process and completely surpass what traditional computing can do. And this is super useful, not just for encryption, but also for chemistry as well. If you imagine a chemical reaction from step 1 to step 2, scientists are now thinking that we're going to be able to understand all of the quantum reactions between step 1 and step 2 like we've never done before, which once we understand that we've got more knowledge in chemistry and we can understand infinitely what happens at each stages, you've got multiple branches that kick off in between, and you've got an entirely new discipline of chemistry. So what does that mean? That means that we can do more in the medical space. Nanotechnology plays a role because these machines operate at a nanoscale level with certain moving parts of it.